Bicycle, bicycle, bicycle. I want to ride my...
Hello. This bicycle generator was created by a group of high school students as a class project. As you can see, we built a frame to hold the bike in a stationary position. This is the front sprocket, and this is the back or rear sprocket. The rear sprocket and the rear wheel are permanently attached, and the rear wheel is connected to an alternator by a bungee cord acting as a belt. By pedaling this bike, it would turn the alternator. An alternator must rotate at least 3,000 RPM, and it would be impossible for a single person to attain this, so the mechanical advantage of the bicycle generator is important. The gear, chain, and rear tire compose a pulley system. To calculate the mechanical advantage, the teeth on the gear of each end of the chain are counted, and the number of teeth on the front gear is divided by the number of teeth on the back gear. The mechanical advantage was calculated to equal 3. This means for every time a person pedals, the wheel is turned 3 times. The mechanical advantage of the second pulley was calculated by finding the diameter of the rear wheel and the diameter of the pulley wheel. That gave us a mechanical advantage of 10. The total mechanical advantage of the system equaled out to 30. This was found by multiplying the separate mechanical advantages 3 and 10 together. So for every one time someone pedals, the alternator will spin 30 times. This enables the bicyclist to reach the needed RPM to turn the alternator. The alternator is a single-wire alternator and is self-energizing. What this means is that the alternator needs to reach a quality called a cut-in speed. When it reaches the cut-in speed, it will energize itself and start to create electricity or start to convert mechanical energy to electrical energy. After the cut-in speed is reached, the alternator can spin at any speed and still convert energy. The cyclist needs to pedal vigorously until the cut-in speed is reached, and then the cyclist can begin to pedal at a more comfortable pace. The alternator has a positive wire connected to it that would allow the electricity to reach the battery or inverter. A switch was added to control when electricity was able to flow through the wires. Beyond the switch, 2 1-ohm resistors were wired in parallel series. These resistors prevent an overflow of current. The resistors were wired in parallel because we researched the proper amount of resistance for this project and found the number 0.47 ohms. By linking the resistors in parallel, the resistance now equaled 0.5 ohms. Although there is a slight difference, it is not large enough to affect our generator. Both the positive red wire and the negative black wire are connected to an inverter that converts direct current to alternating current. The alternating current can now power any common appliance. We use the electricity generated to light up a lamp and to power music through a speaker system. Instead of an inverter, a battery could also be connected to the wires. The bicycle would charge the battery, and the battery could be used to power most AC devices. As you can see is a drawn-out picture of our bicycle generator. This shows the alternator pulley being connected to a switch, 0.5 ohm of resistance, an inverter, and a speaker. This is another drawing of our bicycle generator setup. A battery was added in between the alternator and the inverter. This is a way to store the energy created instead of using it right away. A student will now ride the bicycle generator and show us how this whole operation works. As he starts to pedal harder and harder, the switch is now turned on and the inverter is also turned on. The light is now lit and the music is start playing.
Bicycle, bicycle, bicycle. I want